My name is Mateus, and I'm a lead consultant at OpenCredo. Today, I'm going to talk about using Open Policy Agents, or OPA, to implement computational governance in data mesh. This is a short intro video, but still, I hope this gives you some ideas on how to implement it on your own project. So to start, let's do a quick data mesh recap. So in data mesh, an organization is designed using domain-driven design, or DDD. This results in a division of the business into multiple domain teams. Each team is then responsible for all the systems and the data from that domain. So here you have the concept of data ownership assigned to that team. So any data shared from this domain to consumers is done by what we call data products. So data products are a curated data set aimed at facilitating the consumption of that domain data. So a data product offers a strong contract, schemas, a higher quality data, and really are designed for easier consumption. As a result of this model, teams have much more autonomy to make decisions related to their own domains. And with this autonomy, organizations can more easily scale up without creating bottlenecks. And ultimately, organizations can create a more efficient data ecosystem. So it's easier to process, share, and drive insights out of the data. So, however, in order to create a secure, trusted, and a usable environment for data and a good consumer experience, certain levels of data governance are required. There's no one model for data governance. It can be seen better as a spectrum of options, from a fully controlled model to a completely decentralized one. So data mesh tries to push the organization as far left as possible towards the decentralization, because you want to have as much autonomy as possible, so the teams can independently contribute to the mesh. But at the same time, it's important to enforce some key controls to make the mesh valuable, interoperable, and useful for the business. But the question becomes, where is the sweet spot? So how do we do this without creating extra coordination or potential bottlenecks? So the key approach in data mesh is to use federated computational governance. So that is, teams have some independence to make some decisions, but some controls are still defined by a central body. So however, the key thing here is that those controls are enforced with the use of policy as code. So even though this centralized control reduces some autonomy, it does that without creating human bottlenecks along the way. So let's understand how policy as code works through an example. So here, let's assume you have a development process to create, deploy, and serve data products to consumers. At the top, we have our governance, creating the policies as executable code. Those policies are served to the development process and can be used to control different parts of it. So for example, you can have policies that are executed by developers at their workstation to verify their code, API, and other elements of data products to verify that they are complying with the policies. So this provides a very quick feedback to developers. We could repeat or perform extra checks on a CI system. So we could have additional checks at deployment time. For example, we could prevent a certain deployment from happening, like a new version breaks the API's backwards compatibility. You can also have ongoing checks on the data itself. That is, you can verify that the data is conforming to the quality standards required. It's also possible to execute the policies whenever consumers try to get access to the data. You could implement like authorization, or even more advanced things like dynamic data masking based on the policies. So you could redact or anonymize parts of the data set depending on the consumer's access rights. So essentially, policy as code could be used anywhere in this process. So we really need a flexible tool that can integrate with any system. So this is kind of where OPA comes into play. OPA is the tool to write and serve policies. So essentially, so how it works is your process will that you want to implement your tech will call OPA with some inputs. OPA will evaluate those inputs against policies, and it might take some make use of some extra external data, and it returns the result of the evaluation to decide whether you should continue or not. So the key thing to notice in this model is that we are implementing principle about policy decoupling. That means that any policy can be modified or enhanced in OPA without requiring changes to the color code. This is really important to the process and for data mesh, because we would like the governance to be as light touch as possible, no human interventions. So so any change can be easily rolled out to everyone in a very smooth way. So the domain team shouldn't have to do any work for policies updated, apart from start executing the new version of it. The only effort they might be required to do is potentially adapting their data products to follow the new policy and rules. So as I mentioned, we like to use OPA in many different places. So the tool needs to be very flexible to adapt to most different use cases. So in OPA, policies can be a policy can take any JSON input and produce any JSON output. So that means that we can not only make binary decisions allowed in our access, for instance, but you can create a much more richer decisions. And you can, if you're required, and you can also state the policy, the reasons why a policy has failed. You can give hints to whoever is executing it, so they understand much better what happened. So in OPA, policies are written in a declarative language called Rago. The language is quite powerful to write policies, and it's easy to use once you get familiar with the syntax. So developers can also write unit tests to validate their policies. It's very easy, as you would expect in any development process. So in the previous slide, I described one way of deploying OPA, which is using a client-server model. So in that model, policies are evaluated on the server side, but there are other options. So if you can embed OPA in your binary if you're using Go. If you are not using Go, then you can run as a sidecar, or you can use WebAssembly to evaluate your policies locally without having to do a network call. So this really helps tackle many different use cases and many performance requirements that you might have. So in terms, because OPA is quite flexible, and the way that you define policies is very straightforward. This is a really great tool to power your your data mesh governance, but you're not limited to it. It's not only for data mesh. You can use across multiple systems, multiple areas of your organization to reduce the human element of enforcing policies across your business. So this is what I have for today. I hope this presentation was useful. Please contact us if you need assistance on your project. Thank you very much, and goodbye.